So you are ready to peek under Docker hoods? Nice. Docker architecture might sound like techie mumbo jumbo, but it's actually pretty simple once you get the basics. In this guide, I will dive into Docker, all with a friendly, light-hearted approach. Let's get rolling. Deep dive into Docker architecture and concepts. Docker Daemon. The Docker Daemon is the engine room of your Docker setup. It's a background service that does the heavy lifting. When you ask Docker to start a container, pull an image, or do any fancy work, the daemon is on it, handling your requests like a backstage crew. It builds, runs, and manages your containers. The Docker client is what you, the user, interact with. Every time you type a command like docker run or docker pull, you are speaking directly to the Docker client. The client then passes these commands to the Docker daemon. They work together to keep your containers running smoothly. The Docker registry is the library of container images where Docker looks when you say, "Hey, I need an Ubuntu image." And it goes, "Got it." Docker Hub is a public registry where you find images for almost anything, from databases to web servers and every OS flavor. You can also create your private registry if you don't want to share your images with the world. How it all fits together. Here is how it plays out. You make a request like docker run nginx. The client tells the daemon, "Hey, let's spin up a container using the nginx image." The daemon checks if it has the image locally. If not, it heads to the registry to grab it. Finally, the daemon sets up and runs the container. Et voila, you are in business. That's Docker's architecture in a nutshell. It's just you, your client, the daemon working its magic, and the registry storing your images. Simple enough, right? Practical commands with use cases and examples. Docker has so many handy commands that it's easy to feel like a kid in a candy shop. But let's zoom in on a few essentials that you will use all the time. Docker inspect. Ever wanted a sneak peek inside your container or image? Docker inspect is the way to go. It's like getting the inside scoop literally. Docker inspect, then the container ID. This command will spill all the details about your container. Network settings, environment variables, IP addresses, and more. You can use it when something is not behaving as expected or you want to double check your settings. Docker logs. Containers run in isolation, but if something goes wrong, use Docker logs. This command gives you a play-by-play of what's happening inside. Run Docker, logs, then container ID. Use this when your app throws an error or if you need to troubleshoot. It's like reading your container's diary without any secrets. Docker exec. If you want to dive directly into a running container, to poke around or test a quick command, Docker exec is your ticket. Run docker exec -it, then container ID /bin/bash. This command lets you jump into a container's shell. You can run commands, troubleshoot, or check files. It's super handy. Naming containers. If you are working on a big project, naming containers can save you from hunting down long IDs. Just add --name to your docker run command. Docker run --name my cool app nginx. Now you can refer to it by name, my cool app, instead of a string of numbers. This one trick will make you look and feel like a Docker pro. Docker file and image optimization tips. Docker files are your automation sidekick, but there are some little tricks to make them lean, mean, and blazing fast. Reduce layers like a pro. Each line in a Docker file creates a new layer in the image, which can make your image bulkier than necessary. Instead, try to group commands together where it makes sense. Instead of from Ubuntu latest run apt update run apt install -y Apache 2, use from Ubuntu latest run apt update and apt install -y Apache 2. By combining commands, you reduce layers, which keeps your image lightweight and fast. Use multi-stage builds. Multi-stage builds let you build and copy only the essentials into your final image, which trims all the excesses. It's especially useful when working with compiled languages like Go or Java. In this example, we see two stages, the first one for build and the second one for run. This example first builds your app with all the necessary tools. Then, in the final image, you copy only the compiled binary. This skips all the stuff you don't need. Use minimal base images. For smaller images, go with the lightweight base images like Alpine. Instead of Ubuntu or Debian, try Alpine for a faster, sleeker image. Alpine is tiny but powerful, which helps keep your images small and quick to download. Take advantage of caching. Docker builds each layer separately, so it caches each layer after it's built. If you don't change that layer in your Docker file, Docker will skip rebuilding it, which saves time and resources. But when a layer changes, all subsequent layers need to be rebuilt, even if they wouldn't build anything differently. So keep stable paths like OS updates at the top of the Docker file to speed things up. Avoid constantly changing things at the top of your Docker file like apt update. If the top of the file changes frequently, Docker will rebuild everything below it, even if those lines haven't changed. Let's say you have a Node.js application that you need to build and package into a Docker image. Here is an optimized Docker file. This Docker file shows several caching optimization techniques. Ordering layers. We copy package management files like package.json separately from the project files. This caches the dependency installation layer independently of the project code. Avoiding frequently changing things at the top. Commands like apt-get update are often moved to later in the Docker file to avoid unnecessary cache invalidation. Keeping the context small. We use a Docker ignore file to exclude unnecessary files from the build context. For example, you can put in your Docker ignore file node modules folder, dist folder, and the files with the .log extension. By optimizing the Docker file in this way, you can significantly reduce build times and resource usage, especially during continuous integration, continuous development pipelines, where builds may be frequent but don't necessarily change much between runs. A guide on Docker Compose. Docker Compose is useful for managing multi-container applications. It's like your container orchestra conductor. Instead of launching containers one by one, you use Docker Compose to set them all up in one go. You write down what you need, like databases, web servers, and all their settings in a YAML file, and Docker Compose takes care of the rest. Here is a sample structure of Docker Compose YAML to get you going. In this file, you are defining services. Each service represents one container. In this example, I've got a web service running nginx and Redis service. You can connect these, set up their ports, and configure them all in one place. Once your YAML file is ready, fire it up with docker-compose up. This command reads Docker Compose YAML and brings your containers to life. Add -d to run it in the background. To stop everything, just use docker-compose down. Managing persistent storage and data volumes. Containers are great, but they are like short-term memory. Once you stop or delete them, everything inside is gone. Let's see how to give containers a little memory boost and make data stick around by leveraging volumes. What are volumes? Volumes are like external hard drives for your containers. They let you save data outside the container so that when the container is deleted or stopped, your data is safe and sound. This is very useful for databases. Type of volumes. Docker has a few ways to handle volumes. Named volumes are Docker-managed volumes that live in a Docker directory. Just give it a name, and Docker takes care of the rest. Run. Docker run -v my volume : /data, then Ubuntu. Bind mounts. They link specific folders on your host to a container. This is great if you want direct access to files on your computer. Run. Docker run -v /my /host /folder : /data Ubuntu. So why volumes matter? Let's say you are running a MySQL database in a container. You want the data to persist even after restarting or stopping the container. Just attach a volume, docker run -v MySQL data : /var /lib /mysql /latest. Now, even if you delete the container, your data will still be there, safe and sound in MySQL data. Managing volume permissions. If you need to control who can access files in a volume, permissions come in handy. You can set them directly in your Docker Compose YAML file for more control. Just like that, you've got a data-safe, reliable setup. You made sure your data survives thanks to a persist storage approach. Container networking. Detailed explanation and examples. Networking in Docker allows each container to either hang out with others, be isolated, or even connect directly to the outside world. Docker gives you several network types. Bridge, the default network. It allows containers to talk to each other, but aren't directly exposed to the outside world. This is perfect for most container setups. You can run docker network create my bridge. Docker run --network equal my bridge --name app container nginx. Host network. This connects the container directly to the host's network stack. It's like letting your container use the host's IP address. This is useful for performance-heavy tasks, but be careful. It has fewer isolation benefits. Run docker run --network equal host nginx. Overlay network. Want to connect containers across multiple Docker hosts? Overlay networks helps. It's a bit advanced and mainly used in swarm setups for multi-host connectivity. None or no network. This network type completely isolates a container from the host and other containers. It disables the container's network stack entirely. No IP address is assigned to the container, only the loopback address 127.0.0.1 is available. It's useful when running batch jobs or scripts that don't require network access or isolating containers that should not interact with the network. The following command runs an Ubuntu container with the null network type. Docker run -it -network equal null Ubuntu 20.04/bin/bash. For most cases, the default bridge network works fine. Connecting containers to a bridge network. Let's say you have two containers, a web app and a database. You want them to talk to each other without exposing them to the outside world. Use a bridge network. Create a custom network with docker network create app network. Run each container in that network. Docker run -d -network equal app network -name web app nginx. Docker run -d -network equal app network -name db redis. Now your web app container can talk to DB simply by using its name DB. DNS and aliases. Docker has a built-in DNS, so containers can communicate by name. This means if your web app needs to talk to DB, it just needs DB as the host name, and Docker handles the rest. Need a different alias? Just specify it when you connect to the network. Docker network connect -- alias equal mydb app network db. Now mydb is an alias for the DB container. This is super useful when you want clear, readable names in your apps. Exposing ports to the outside world. If you want to access a container from your host or the internet, use port mapping. Say you are running an nginx container and want it available on your machine's port 8080. Docker run -d -p 8080:80 nginx. Now when you visit http://localhost:8080, you are seeing your nginx containers content. Pretty neat, right? That's container networking in a nutshell. By combining networks, aliases, and port mapping, you can set up any kind of connection your containers need, whether they are staying local, reaching out to other containers, or even connecting with the outside world. Security best practices. When it comes to containers, security is key. If your containers aren't secured, they might spring a leak. Let's make sure your Docker setup stays ship-shape with a few simple practices. Use official and verified images. Whenever possible, stick with images from Docker's official repository or other verified sources. These are regularly checked for vulnerabilities, so they are safer than random images from unknown sources. Look for the official tag or verified badge on Docker Hub, like Docker pool Ubuntu:latest. This is good to go with the official Ubuntu image. Avoid root users in containers. Running a container as the root user, the default, opens the door to security risks. It's better to create a non-root user in your Docker file and use that instead, like run user add -m docker user docker user. This way, if someone tries anything fishy inside the container, they will have fewer privileges. Minimize permissions for volumes and bind mounts. If you are sharing data between your host and the container, only give access to the specific files and folders needed. You don't want your container messing with sensitive files on your host. Set permissions carefully, like so. Docker run -v /my/host/folder :/data :ro nginx. In this example, ro means read only, so the container can read the data but can't modify it. Regularly scan your images. Docker has a built-in security scan tool that checks for vulnerabilities. Run it periodically to catch any issues before they become problems. This scan will give you a report of any known vulnerabilities in the image. It's a quick check that can save you a headache later. Limit network exposure. Only expose ports that need to be accessed outside the container. If your container doesn't need internet access, use the --network equal none option to isolate it. Docker run --network equal none nginx. With these practices, your containers will be much safer, and you will have peace in mind knowing you sealed up the security gaps. Wrapping up. Docker is a powerful tool that can simplify your development and deployment processes. With containers, you can ensure consistency across environments and make your applications more portable. Remember, practice makes perfect. Don't hesitate to experiment, break things, and Google errors. You will learn a ton along the way. Happy Dockerizing! Found that helpful? Smash that like button like it's a bug in your code. Don't forget to subscribe for more tech insights. Got questions or topic you would love to unravel? Drop a comment below. Excited about diving deeper into the world of software architecture? This video is just the beginning. Check out my Udemy video course on software architecture. The link to the course is in the video description below. See you next time.